I'm going to start off with a video on catalytic converters, and this is one of the better ones I found. It's not 100% correct.
This is
And I'll
turbina, no?
correct some of the stuff. It's just much more correct than the other garbage I've been able to find.
It's not a turbina. That's
Unfortunately, a lot of the people that seem to have great talent for making videos really don't know how the things work they're making videos on. So I tend to be at the other end. I'm lousy at making videos, but at least I know how the stuff works. So I'm working on skills on videos, and I know Jessica is also. I'm seeing the changes on the one she's doing each time, kind of adding more and more features, and I'm behind her. So that's why she's doing it. So I started out with a video here on catalytic converter deconstructed. I like some of the stuff's in here as far as really kind of explaining how it works. I think it answers some of the horsepower questions we have and some of the other stuff. And kind of really, it's an amazing little device. And I'll let it play through. And when it's done, I'm going to talk about a couple of things, or I may even stop it and talk about a couple of things that are incorrect on it because they leave one of the elements out and some other stuff. But let's take a look at it, and it's going to have loud music because that's what videos do, I guess.
Take it apart so you don't have to. A multitude of cars. In each one, a motor burns fuel.
Can you make it louder?
Oxides, carbon monoxide, and unburnt fuel residue. Luckily, each car also has a catalytic converter. Located under the hood, attached to the motor, right before the exhaust system. Gases produced by the motor go straight into the catalytic converter and come out the other side less than 1/10 of a second later. The converter gets less than 1/10 of a second to recombine toxic gas molecules and produce harmless substances like water vapor and oxygen. How? To understand it, we've got to destroy it. The stainless steel housing contains 2 ceramic blocks. Each block is filled with thousands of...
Okay, those blocks are also called biscuits. And one of the things they're not showing you here is there's a blanket that wraps around the biscuits that goes between the biscuits and the stainless steel shell of the catalytic converter, because these are made out of ceramic. So they're going to expand and contract at different rates than the stainless steel shell does. So when a converter rattles, it's because that blank has been compromised or this has been melted down, so it's undersized. That's also why when we replace catalytic converters, we actually have to perform a break-in procedure on them, where we actually get the catalytic converter hot, which causes that blanket material to do what's called a pop. And what it does is it pops to firmly hold the biscuit in place. Failure to do that will actually cause a catalytic converter to prematurely fail. Not as much of a problem here on the West Coast where it's fairly warm, but back east or where it snows, an exhaust shop might put a catalytic converter on a car and just park it. Customer drives it home a couple miles, never really gets hot. By the time spring comes around and it gets hot and it starts getting hot, it's too late. The thing's already undersized. It's been moving around. The converter's junk. So there is actually a break-in procedure when you replace a cat, but I want to point those out.
...of microducts. Their sides are coated with precious metals. Precious? Platinum and rhodium in the first block. Platinum and palladium in the second block. Metals that can cost more than $100,000 a pound. But they're worth every penny. Together, they have the extraordinary property of causing toxic gases to react and then recombine, producing gases that are harmless to your health. All that without altering themselves or rusting. Precious. The trick is to maximize the contact zone between gas and metals. That's why there are so many microducts, almost 400 per square inch. Their combined surface area matches that of a football field. A laboratory as big as a football field, but folded onto itself in order to remain small. The transformation of gas from toxic to non-toxic happens most efficiently when the catalytic converter is hot. Very hot. 1,300 degrees Fahrenheit. It's the toxic gases themselves that heat up the catalytic converter. They exit the motor at temperatures as high as 900 degrees Fahrenheit. The chemical reactions inside the catalytic converter also generate heat, transforming the converter into a super efficient furnace designed to break down and reform gas molecules. Let's take a closer look at these mysterious transformations. The nitrogen oxide and carbon monoxide molecules, along with the molecules of unburnt fuel residue, enter the catalytic converter. They're swallowed up by the thousands of microducts. As they reach the platinum and rhodium in the first block, nitrogen oxide molecules are the first to react. These metals break down the molecules by withholding one of their atoms. The freed atoms stick to each other and recombine. The result? Nitrogen oxide molecules become oxygen and nitrogen, which already make up 99% of the air that we breathe. The gas molecules now head into the second block, where the microducts are coated in platinum and palladium. These precious metals withhold oxygen. The intense heat here forces the carbon monoxide molecules to combine with the oxygen. The result? Carbon dioxide, the same gas that creates bubbles in soft drinks. Now for the molecules of unburnt fuel residue. At these extreme temperatures, their encounter with the oxygen forces them to recombine. The result? More carbon dioxide and water. All that in less than 1/10 of a second. In theory, the catalytic converter can eliminate 99% of a motor's toxic gases. In reality, it's inefficient as long as it's not hot. A car has to travel about 6 miles before the catalytic converter reaches its ideal operating temperature. That's 6 miles spewing untreated gases. In spite of the catalytic converter's best efforts, the car remains a source of pollution. But thanks to this miniature laboratory, it emits 5 times less pollution. That's still pretty impressive.
Okay, what did you guys think of that?
Super cool, very informative.
Yeah, I like that. I like a lot of the stuff in it, and a lot of it is more in the 90%.
You mean
Of being accurate.
you mean any people with gas cars, they need to get smart every 6 years.
What about every 6 years?
You gotta get your car smogged.
Not every 6 years. Once it's more than 8 years old, if it's powered by gasoline, it's every other year.
Or every other year. Like
Yeah,
the 90s?
biannual inspection. So we do it every other year for the purpose of smog. We used to have a 6-year rolling exemption. So if I had a brand new car and I haven't sold it, I didn't have to smog it for the first 6 years. Now it's the first 8 years. If I sell it,
No,
and
but I
it's less
thought
than 4 years old, I don't have to have it smogged. But if it's more than 4 years old and I sell it, I have to get it smogged.
yeah.
After
But I thought
Korea,
he wants you to smog 3 years, isn't it?
What's that?
I thought the DMV wants you to get your car smogged every 3 years if it's like 10 years older.
It's every other year.
Every other year?
Every other year. Biannual. So that means if it's like my 2012 has to be smogged in 2020, 2022, 2024, and so on. My 05 has to be smogged in 17, 19, 21, and so on. So my 3 cars that are odd years, my 87, my 95, and my 05, all have to be smogged the same year. And then my Camry is a 12, so it gets smogged in an even year.
Mm.
So one big thing they're missing in the catalytic converter video is cerium. So cerium is a rare earth element that is used to store and release oxygen. Normally we're using about C5, C6. I mean, there's 5 or 6 cerium atoms stuck together. So we use cerium to store and release oxygen. And the significance of that is twofold. First of all, our cerium is the material that melts at the lowest temperature. It melts at 1462 degrees. So it's the first material in the catalytic converter to go away. It's also the only material that is measured for efficiency on an OBD2 system. So when the OBD2 system is measuring the catalytic converter for efficiency, and if the efficiency is low, it'll set a catalytic converter code. Cerium is the material that they're actually measuring. If you notice, they didn't talk about cerium at all. Okay.
No, we didn't. Only the oxygen, the nitrogen.
Right. They
Right.
talked about the hydrocarbons and the CO, and it talked about NOx a little bit. And here's the other thing: how they built their cat, it really wouldn't work because as the NOx comes into the first bed. If there is oxygen, which there would be, because without cerium, you'd have plenty of extra oxygen, then the rhodium would not react with the NOx, it would react with the free oxygen. So I can only reduce NOx in a slightly rich or oxygen-starved mixture. If I, so I'd have to actually oxidize my HC and CO first, then I can reduce NOx, but then I have this free oxygen that I'm going to turn around and use to oxidize more HC and CO. So how that catalytic converters are actually built is they're built as a blended bed. So all of those elements are on the same bed of the cat. The concept of having a strictly reduction bed and a strictly oxidation bed go back to the early days of three-way catalytic converters when we injected air into the middle of them. And unfortunately, when they write these books, no one got the memo that it can't work that way. Again, done a lot of research on this. So that's one issue we have. The other thing it talked about, you know, catalytic converters are about 90% efficient. So if my engine is 90% efficient and I put a catalytic converter on the back, now I'm 99% efficient, combustion efficiency out the tailpipe. So catalytic converters, a warm-up catalytic converter is going to warm up very quickly, 1 to 2 minutes normally. Because obviously as I start driving, I put a lot of hot exhaust right into the cat. The catalytic converter underneath the vehicle will take much longer to warm up. That's why we have warm-up strategies with OBD2 that we really started using in 2008. So our goal is to get that catalytic converter. Actually, we started using them earlier than that. I'm sorry. So we started using them even back 2000. So the goal is to get that catalytic converter hot in 2 minutes. So we might use electric air injection for that. I might use certain fuel management for that, where I run artificially rich so the extra fuel actually burns in the catalytic converter or oxidizes in the converter to generate heat. And the ways we have of doing that aren't terribly clean. So by the end of 2 minutes, my catalytic converter is lit off, but I haven't run any cleaner than if I wasn't doing that. Our advantages from the second minute to the 5th or 7th minute, now my cat's hot. Now I'm running much cleaner those next 3 to 5 minutes. That's where the strategy is. So I do like how they unfold the cat to really kind of give you an idea how much surface area it has. They also talk about the exhaust gas going through the cat in 100 milliseconds or less, or 1/10 of a second, which is 100 milliseconds. And when I talked about O2 sensors, I said they had to switch, right? 35 to 40 milliseconds, because I need that rich and that lean every time that exhaust is going through the cat. If my O2 sensor is slow or it's not switching and I'm stuck lean, I can't reduce NOx. If I'm stuck rich, I'm going to make a lot more hydrocarbons and a lot more carbon monoxide, but my catalytic converter can't get rid of any of it. Because what does it need? It needs oxygen. Well, I'm making those gases in the first place because I don't have enough oxygen. Remember, CO is a lack of oxygen. Hydrocarbons, unburned fuel. So an example where I would have a lot of oxygen with my hydrocarbons would be if I have a misfire, like an ignition misfire, a bad spark plug, or a bad ignition coil or something like that. Now I'm going to put raw fuel into the catalytic converter and oxygen that hasn't been used in the catalytic converter. Now I basically have a blast furnace. So now that catalytic converter is going to run much hotter than designed. As it gets above 1462 degrees, I start melting cerium. Once I hit 28 and change, I melt rhodium. 32 and 3500, I melt platinum and palladium. Once I get over 4000, I start melting the ceramic. I've seen, I had pieces of a converter that were melted down to the point of plugging in. The car had to be towed in less than 20 miles after that converter was installed.
Why?
I have another instructor that had one after only 8 miles. You can destroy a catalytic converter very, very quickly with a misfire. And that's why the check engine light flashes when the car's misfiring. So maybe I only damaged a little bit. I got up to 1800 degrees. Well, I've melted cerium. My platinum, palladium, and rhodium are all there. So I may still run fairly clean under most conditions out the tailpipe after the car's fixed. But guess what? Now it fails the catalytic converter test that the computer's doing with the self-diagnostic monitor because it's looking for cerium and there isn't as much there. So cerium is kind of like our fuse in the catalytic converter. It's the thing that goes away first, and it's also what OBD2 tests for. So it's not about how clean the car is running out the tailpipe. It's about how much oxygen that the converter can store. Yeah, Ruben.
With some of those vehicles that kind of go without the muffler, some of the race kind of style cars, doesn't that also screw up the catalytic converter because the noise output
No.
that's putting out?
Absolutely not. No effect on it.
Okay.
No effect at all. And you can see with all those honeycombs, is that catalytic converter really restrictive?
No.
No. So when might it be restrictive? Maybe if I take off a big factory one and put a little cheap aftermarket one on that doesn't have as much surface area, now that might be restrictive.
Right. Right.
Okay.
And that would be that would pose that problem.
Right.
Okay.
So
Makes sense.
Mr.
if
Brian,
it's melted down, it becomes restrictive. Yeah. Yeah.
is it supposed to melt down like over time, or is it not
Nope.
supposed?
Catalytic converter is one of the genius things. Great question. One of the genius things about a catalytic converter is that although we're using platinum, palladium, rhodium, and cerium inside this converter to create holding and catalytic reactions, we don't use any of the material. It'll last forever. So there's only two things that damage a catalytic converter. Overheating. Overheating is most commonly caused by a misfire because I'm putting a lot of air and a lot of fuel in. The other thing that can cause it is contamination. Contamination from coolant, contamination from silicone, things like that can damage a catalytic converter. Those are the only two things that can damage a catalytic converter. So when you have a customer, and maybe they have an ignition coil go bad, and it comes in running on 3 cylinders or a misfire, and you replace, they only want to buy 1 spark plug. Well, maybe the catalytic converter got permanently damaged to the point it's going to set a code. Maybe it didn't. But if they only buy 1 spark plug and then the next coil goes bad in a month or 2, and then it comes in get the next coil changed, and then the next coil changed. And I've seen people with V8s do this 4 times before they finally decide to buy the rest of the coils. Each time that car is misfired, each time a coil goes bad, they're overheating that cat. They're melting more cerium out of it. So where they might have gotten away with not having to replace the cat after the first coil, by the time they get to the 4th coil that's gone bad, odds are that cat's going to be junk now also. So they've really increased now what? They're trying to save money. I can't afford to buy all 4 or all 8 coils. Well, you must be able to afford to buy a couple $1,000s worth of converters. I mean, right, everything has, do you want to pay me some money now that may be hard? Or do you want to pay me more money later that I guarantee is going to be harder?
Right.
I think that's the thing that people don't realize. A couple of things about cats. One, they're so easily damaged by overheating. The other is they only work at very specific fuel mixtures. And if I go out of that fuel mixture range, they don't work efficiently. And it's catastrophic how much they change.
How about contaminations from oil?
Not really an issue because oil's a hydrocarbon. So it won't ruin the cat. It can coat it. The cat should run hot enough as long as it's still reacting that it'll burn off the oil that's getting on it. You may get some ash buildup or things like that over time could lower its efficiency and eventually set a code because it's coating it with that. But I've had cars that are running extremely rich and the tailpipe's all black. I mean, everything's got tons of carbon in it, and carbon is carbon. And once I fix how the car is running and get it back in fuel control, get the cat to light off, it burns all that stuff off and it's working fine. So that's why I really only mentioned coolant and then silicone. So if I'm using a silicone that's not O2 sensor safe, I'm using a cheaper silicone that's not made for that, or some silicone that's not made for automotive, because somehow we think silicone is silicone, that'll ruin a cat.
Are you talking about like sealants? Or
Yeah.
gaskets?
For gaskets, they come in contact with the oiling system.
Okay.
So I can get away with other, silicone or gasket material for like a thermostat housing or a coolant passage because it's not getting in the crankcase. So it's not going to end up in the combustion chamber. It's not going to end up in the cat. But any oil pan gaskets, valve cover gaskets, timing covers, anything that is exposed to the oiling system will put those contaminants into the exhaust system, and that'll affect the O2 sensor and the catalytic converter.
I have a question.
Okay.
Before on the video, you say when you change the catalytic converter, you have to hot team. I don't understand the procedure break. I don't understand this.
Oh, okay.
Sorry.
So in the catalytic converter, there's a blanket that goes around the biscuits
Okay.
between the shell.
Okay.
And that blanket's flexible. It's soft because it has to be moved through shipment and different temperatures.
Okay.
Once we put it on the car, we need to get the catalytic converter hot enough to light off. And that's that smell you get on a brand new converter because you're burning all the coating off of it.
Okay.
You burn the coating off of it, that blanket does what's called a pop. So it chemically changes to where instead of being flexible, now it's going to firmly hold it in place. It expands to where it fills up all the gap between the shell and the biscuit. It still has cushioning that allows them to expand and contract differently, but it's going to hold that biscuit firmly in place. That's what I mean by the pop. That's the break-in procedure we do.
How can do this procedure?
So when you put a new cat in, you always want to, I usually will use a stick or something, a throttle stick, and put in the bay and bring the RPM up to 2,000 RPM or so and let the thing sit there. And it may take 5 or 10 minutes and all of a sudden you'll smell it. That catalytic converter will start putting out a smell. That means it's popped. That means it's lit off.
Ah, okay. Like if you do like the customer do like 10 mile after, 20 mile after, it's okay.
Yeah. You don't want to go on the road and do it because now what? You got things moving around in there and you're going to try to expand this. It's not going to get a good seat.
Okay,
So you want to get that smell. And if you've ever smelled that smell, you know what I'm talking about. It's
yes. Yes.
Yeah, it's unmistakable. Once you smell it, it's like, oh, that's new cat smell. You want to get that smell before you go drive the car. And then go drive the car so the smell will dissipate before you give it back to the customer, and the customer doesn't complain that they just paid you $1,000 and now their car stinks too much to put it in the garage. Okay? So, but that's what we're doing with it.
Thank you.
Okay, so I'm into the PowerPoint. We talked about this a little bit yesterday. I did also post the video that I just played for you guys in our Canvas. It's on videos for this chapter. So not our class videos in PowerPoint, but actually separate videos I did for this chapter from the PowerPoint because the videos don't display well. So if anyone wants to see it again, they can see it. So this is a traditional oxidation converter. These were pellet types. These were restrictive. And so the plug you see at the bottom right here was originally designed so you could take it off, pull the plug out, and put more pellets in. No one ever did it, but all the GM dealers got the factory tool to do it with in a bag of pellets. But these are restrictive because this is much more like filtering through sand. I'm pushing the exhaust through this pile of pellets, and the air has to find its way to weave through. These were very efficient because something couldn't go directly through and never touch anything. So it had a good catalytic reaction. Now, these catalytic converters only have platinum and palladium in them because all they do is oxidize. So they do nothing for NOx. They strictly oxidize HC and CO. The internal temperature of a catalytic converter in order to work properly is 600 degrees. Once it's hit 600 degrees, it can start working.
Wait, isn't it 12 or 1200 to be efficient?
6.
It's 600 is where they start working at. Below 600, they're pretty inefficient. The hotter the catalytic converter gets, the more efficient it becomes.
But in the video, he said
It said 1300 in the video.
He said, yeah, by itself, the gases from the engine is 900 Fahrenheit.
Right.
And then the chemical reaction heats it up to 1300.
Right. And let's think about this for a second. And because I know the article also has 1300. So you put what the article says in it. But at 1300 degrees, and that was true on oxidation cats because we'd pump air into them and get them really, really hot. Hot enough that you weren't allowed to idle the car for more than 5 minutes or the carpet would catch on fire. But would we design something to work at 1300 degrees normally and at 1462 degrees, only 10% more, we're going to do catastrophic damage and have to throw the part away?
No, that's not smart.
No, it just doesn't pass the smell test. I do know that internal function of the cat, all the stuff I've read on cats, the actual research stuff on cats, they need 600 degrees Fahrenheit to start working. As they oxidize, they generate more heat. Exhaust coming out of the engine is hot, say 900 degrees, but it's also hitting the exhaust ports and the exhaust manifold very quickly, which is dissipating heat, and it's coming down to the cat. So it's lost some heat by the time it gets there. You know, certainly for a cat to run internally at more than 600, I would expect it to if it's catalyzing. But here's the other issue we have is that oxidation generates heat, reduction reduces heat. So when I reduce NOx, when I separate that oxygen and nitrogen bond, it actually cools the converter. When I oxidize HC, it heats, or CO, it heats the converter. So that's why we don't do a temperature test on cats. It's not accurate. It's flawed because I don't know what the feed gas mixture in. In the old days, they used to say, well, the inlet temperature should be 200 degrees lower than the outlet temperature. And that was one of the early tests, and it was really designed around these oxidation cats. On a three-way cat, it could be the same temperature in or out. Or I've actually had cats working normally where it's 200 degrees cooler out than it is in. So you can really see, depending on the mixture and depending on what catalytic process is happening, it greatly changes the temperature of what's going on inside the cat. What I do know is in order for the platinum and palladium to hit reasonable efficiency for the oxidation process and rhodium to hit reasonable efficiency for NOx reduction, we need 600 degrees.
All right.
And that's the same temperature that I need for a catalytic 2 sensor to operate properly, a zirconium sensor. And you think about it, where did we used to put cats? Not by the engine.
Next to
Under
the
the
drive
gun.
shaft.
All the way underneath next to the drive shaft.
Hmm.
Do you think possibly that we were getting 1300 degrees down to that? Nowhere close.
I doubt it.
Not through single wall pipe. You'd be catching the carpet on fire as it goes down the floorboard. If that pipe was hot enough to hit 900 degrees or 1300 degrees. Plus, what's the heat coming out? The heat coming out is nowhere near 1300 degrees. So even though we have some loss through the pipe and all that, I know the thermal imager isn't right there. But having thermal imaged a lot of these and stuff like that, this is more accurate. I know both the articles, and it's hard when the instructor's saying one thing and the book or videos are saying something else. Well, it comes back to one of the things I've talked about in this class. Much of the information we get and I don't think this is limited to automotive, but I know for a fact it's in automotive, is that you have people repeating the same information and explaining it to you differently. No one is going and checking to see if the information's correct. And I don't care what you're looking at. I think there's a lot of truth to that outside of automotive. But I know for a fact it is in automotive. An example we just had was guy who writes the books, Tim, was working on the Power Stroke 6.7 liter diesel engine. And he got 8 books. The 8 books he could find written on the Power Stroke, he got all of them. And he wanted to go through and familiarize himself and see what's going on before we started doing testing, which is one thing we do real different. So before he writes a book, he looks at what's out there, learns how it's supposed to work. Then we get vehicles and actually put scopes on them, actually create faults, actually look at what's failing on them. And what we found in one case we found a lot of stuff wrong in the other books, but one thing we found was not only did the system not work how every book said it worked completely opposite of that. So you got 8 books out there all saying the same thing, but when you actually hook it up to a car, you find out they're all wrong. So, and that's what, going back to what we talked about the first day of class, it's my job to get you to ask questions. I can't teach you everything here. I can't teach you everything I know, and I certainly don't know everything. But let's ask questions. Just like we talked about, would anyone design something to operate at 1300 degrees when catastrophic failure is at 1462 degrees, and they have to warranty that part for anywhere from 8 years, 80,000 miles, up to 15 years, 150,000 miles, depending on the vehicle? There's no way any engineer is going to design something at that tight of tolerance between normal operating condition and catastrophic failure. They'd be eating them left and right back at the dealership. So those are the kind of things that, like, wait a minute. I mean, I've put thermal imagers on these. I've done a lot of stuff on these, and kind of looked at that. So no, it is 600. That goes back to the old days of the oxidation cat, because that's how hot we had to get that catalytic converter underneath the car to start the process. Now, we would get them a lot hotter than that, because you'll see coming up, we actually used to use an air injection pump and pump air into the back half of the catalytic converter where we oxidized. And on those cars, we reduced NOx first, and then we oxidized HC and CO after. But we ran the cars rich, and then we injected air so we could oxidize the HC and CO. Unfortunately, going back to the early days of 3-way catalytic converters in the 80s, people never got the memo that we don't build them that way anymore. So, for example, many cars have 2 converters on them. We have a warm-up converter right by the engine and a catalytic converter underneath. They're both 3-way catalytic converters. But let's look at function. The front converter's primary job is to oxidize HC and CO. It can't reduce NOx because there's too much oxygen. It can reduce some, but the rear converter, it's not going to oxidize any HC and CO because all the oxygen is used up. All it's going to do under normal operating conditions is reduce NOx. Now, if I have a misfire, and because that front cat's small, that warm-up cat's small like we saw in the picture, if I have a misfire, it's going to overwhelm that front cat, and we're going to punch through some of those emissions. Now I have that rear catalytic converter that's a full 3-way cat that can oxidize HC and CO when the car has a misfire. So it's kind of like having a safety catch, right? It's kind of like having a safety on it. That's why a lot of manufacturers put that second cat on. It's A, to meet the NOx standards. It's B, in case there's a catastrophic problem, the car's not going to, pollute heavily. And also, those rear catalytic converters on most vehicles are not monitored by the computer. So the computer would have no idea whether you take that rear cat off or not. That's why we do a visual inspection on the smog program, is to make sure that rear catalytic converter is still there, because the computer is not looking at it, so we have to.
Brian, I'm just kind of curious, with what we have today with the 3-way cats and the technology we have with the catalytic converters, are they still trying to improve and creating better? performing catalytic converters?
Absolutely. One of the things we're doing is we're increasing the cerium load. Cerium is a rare earth element. And by adding more cerium, we found that we can put in less rhodium and still get great NOx reduction. So that comes into cost savings and while picking up efficiency. The other thing we're doing, if you looked at the honeycombs on that, they're rectangular and you can see all the way down. What we're doing on some catalytic converters is, and what happened is if a molecule goes straight down that and never touches the sides, it won't be catalyzed. So what they're doing is they're actually making some of the new ones where they swirl it. So now those squares, those little squares actually go around like this. And they swirl around, which forces the exhaust molecules coming through there to have to bank off the sides to go around, which means that they're going to have a better reaction rate because they're contacting the sides.
That's pretty tight. Now, are we using now the second, I guess the second question would be, are we using those more on the hybrids, or are we performing those kind of technologies on any type of vehicle, or will we see them on like hyper performance cars or sport cars or the like?
It seems to be more by manufacturer. I've seen Chryslers play with that. I've seen it on a Chrysler. I have not personally seen it on other manufacturers, so I don't know who all is using it, but I have seen it occasionally when I've taken one off, but I have seen it on a Chrysler, so I don't know how many different manufacturers are doing that. So that is, one of the things we're seeing there. Unfortunately, because catalytic converters are so misunderstood, there is so much bad information out there on them.
Right.
All you got to do is hit YouTube and you'll see a million ways how a cat doesn't work, or how not to fix it, or how not to diagnose it.
It's actually kind of scary.
It's real scary. And unfortunately, you have people out there, I'm looking right now, you got stuff, 1.2 million views, 1.2 this. And it's like, it's BS stuff. It doesn't work.
Right.
Bad science, but it's a good video. Or it's, hey, use baking powder and clean your cat, save $500. Boo, I'm going to get 1 million hits.
Right.
Right? Because what? People would rather buy a can of Arm & Hammer than buy a catalytic converter. So, I mean, a lot of that YouTube really goes towards the DIY. I'm hoping it won't be what everyone told me it is, and I'm looking for something here that I can do to try to save money. So there's a lot of stuff on there like that. There's also a lot of stuff that tries to explain stuff at a basic level that's 70% correct.
Right.
And in this class, I try real hard not to be 70% correct. And, it's just like leak down testing and stuff. By no means do I have the only running compression video or leak down video on YouTube. I think the difference is I really try to go through and explain actually for the process and what we're trying to do, as well as I have a link to a lab sheet. But there's a lot of subtleties that people don't know or don't do because they've done it once or twice, and now I want to make a video. Well, when you do something 1,000 times and you've had something happen bad 3 times, you don't forget that. So you're going to mention that or cover that. If someone's only done something 10 times, they think they know it. They think they got it down because they've never done it enough to have something bad happen. And that's true whether you're doing tires, brakes, suspension, alignment, putting in spark plugs, you name it. When you do things enough times, those small percentages of outliers of bad things that happen when you're doing a job, you're going to experience.
For sure. It's like I've always said, if you really want to know, you go to the source or get hired by the actual manufacturers and really get to know the system that you're really interested in.
Yeah. I mean, that's a great way of doing it. I mean, manufacturers will invest. That's not to say there's not some great stuff on the aftermarket. And we talked about this before. There's some great training available, but it costs money and there's not as much of it as there should be. But the amazing thing is I'll go to a town, or even San Diego County. We got over 3 million people.
Yep.
I did my Power Stroke class, and I had great turnout from my Power Stroke class. I did 2 classes in San Diego County, and I bet you I might have had 80 technicians.
Mm.
And that's huge turnout.
Yeah, it is.
When I started teaching for them, they had less than 20 total in San Diego County when I taught networking. So obviously they like me, so they keep coming back. I don't know why, but I got them fooled. But there's 3 million people in San Diego County, over 3 million people. There's how many shops? Probably over 1,000, right?
Yep.
How many technicians? Probably 5,000, 8,000, easy, I guess.
Easy breezy.
Between dealerships and everything else. And I'm probably way low on both numbers. And yet 20 to 80 people find their way to a class to learn something between 2 different classes.
It's like the SEALs narrowing it down.
Well, and it does. And what that always meant for me, because I'd always see the same people at these classes. And what that meant for me is if I'm one of the 20 people, if I'm one of the 80 people or whatever that are going to classes, and I'd see some of the same people at the different classes, regardless of who's putting them on, I knew the guys that were interested in learning. And that told me that I'm up here. I'm not somewhere in the middle, or I'm not down here, because I'm making an up here effort. Even though there's plenty of guys in the class that, I mean, they're talking about stuff and my head's ready to explode. And I understand one out of every 5th word. And I've been to those classes, especially early on. But I kept going because I wanted to go. And it didn't matter if it was the same subject, but taught by a different, I went to Napa's class, and now CarQuest has one on the same subject, or ATG has one on the same subject, or O'Reilly has one on the same. There might be 5 classes all on the same subject by 5 different places. I'm going to all of them because maybe I need to hear something the 3rd time before the pieces click and I understand it. Maybe I need it explained to me a different way. So that's, but it's, I'm a big believer, and you can see that with how I, put things in on the modules with all the extra credit I give.
That's cool.
Because I don't expect people to be perfect and get 100% on everything. I think that's an unreasonable expectation. I think you should be able to rise to the top through hard work and repetition.
Agreed. I was just telling my wife yesterday, I go, based on your comment about going to a lot of the forums that are out there, a lot of the different meetings, I'm like, hey, you know what? Let's go check those out. She's stoked about it.
Yeah, no, that's great. I mean, there is so much stuff out there, and so much of it is accessed so little by people. And yet I hear people, gee, I need to get more training. Gee, where'd you learn that? Or I'm going to be doing a class Saturday, and I will lose people in it that have been doing this for 20 years.
Right. Like you said,
at the same time, they come to me every 2 years because they have to renew a license, but they do no other training in between.
Right. And that's
Really?
what's scary. That's scary.
Well, I always figured, you're gonna pay for your education one way or the other. You're gonna pay for it when you're working on a car and something goes bad, and it takes you 2 days to unscrew it up. Or you're gonna have to go to classes and go to school at night and do things like that to learn how stuff works. I always figured I could manage my time at night. I need to make money during the day. I can't afford to be learning during the day and not making money. So I always went to the classes so I could learn and invest there. So I'm not having to invest the hard way, which is normally the longer way during the day, where now I'm working on a car for 3 days and I haven't made a dime because I didn't have 3 hours to go to class.
That's right.
And that the other thing that did for me is going to those seminars is meeting people.
Yep.
I've met people that wanted to hire me. I've made friends with other techs when I was looking for a job. I had someone I could call when they were hiring and ask, and get in with them. I've gotten a lot of opportunities. Matter of fact, I teach for Automotive Training Group because I was at one of their seminars a number of years ago. And I knew the guy, the trainer was the first time I'd seen him, but I knew one of the guys in the back who had actually used to write for him. And we were catching up. I'd known him a number of years. And it turns out the new CEO was in the room. I had no idea who he was, young guy. And at least he looked young. He's my age. But shows you how long ago this was. And we talked, the class got done at 10. We talked till 3 in the morning outside. Just hit it
Nice.
off. We've stayed in touch ever since, which has opened a lot of opportunities. I wouldn't be in education if it wasn't for that chance encounter and for him seeing how I related and what I saw and him encouraging me. And he actually called me with someone he knew who had a school who was looking to hire someone and put me in contact with him and
That's
got
what's
me
up,
my first
networking.
teaching, real, long-term teaching job other than just doing one-day seminars or things like that. And I worked there for over 8 years. So I wouldn't have that had it not been for that chance encounter of me going and taking a class.
That's awesome.
So that, and again, it's also a great way of networking because I've gotten names and numbers of people that go to these classes. So when I have a question on how something works, I have a lifeline. I have someone I can call. I have someone I might be able to borrow a tool from. I have someone that, if it's a specialty tool or something. I mean, I built my sphere of influence and my connections where I could get help, but also I could help them out. And that's so important in this industry.
Yes, indeed. That's just, phenomenal. That's what it's all about, really.
It is. And what do I always tell you guys? You got to invest in yourself to get other people to invest in you.
That's right.
So let's get back to CAT. Speaking of investing. So here's a 3-way catalytic converter. We can see the biscuits here. This is a little more accurate why I like it. We got our platinum, palladium, and rhodium all on the same wash coat. The wash coat is how they put the precious metals and the rare earth element cerium onto the ceramic material. They literally dip it into what's called a wash coat. So they kind of wash the ceramic with the material. That's how it gets on there. So you can see here, I have 2 biscuits. They're both the same. That's why if you buy an aftermarket CAT, most aftermarket converters are omnidirectional, means I can put them either way. Well, if it was really important, I had this biscuit here and this biscuit here, the direction would matter, wouldn't it? But on new CATs, if I buy new replacement CATs, I can put them either way. They started doing that back in the 90s. So really new technology just came out. Apparently the video, and that was the Science Channel. I mean, that's a big budget production. They didn't get the memo. So this is a nice picture. I put this in here because it shows the blanket that goes around the biscuit, or ceramic monolith is its technical term. And that's what pops when we break in the CAT. What component is required to be present on a vehicle for a 3-way converter to operate properly? And the correct answer is oxygen sensor. And the reason why is because I have to be able to go rich, I have to be able to go lean, I have to be able to go rich, and I have to do that at a certain frequency in order for my catalytic converter to go rich. I can reduce NOx. Lean, I can oxidize HC and CO. Rich, I can reduce NOx. Lean, I can oxidize HC and CO. And again, if that gas is going through the CAT in 100 milliseconds, I really need that O2 sensor to be switching at least every 100 milliseconds or so, right? So that I'm not overwhelming the cerium. What the cerium is, the cerium allows that to hold oxygen when I'm lean and release oxygen when I'm rich. So the cerium is what allows, when the car is rich, I can still oxidize because the cerium is going to release oxygen. When I come down lean, I can still reduce some NOx because the cerium is going to grab oxygen. The chemical reaction with cerium to oxygen is much faster than the chemical reaction with rhodium to oxygen. However, rhodium is much stronger than cerium. So rhodium is strong enough to break the bond with the nitrogen atom and separate oxygen and nitrogen. Cerium's not. Cerium's just out there grabbing the free stuff. But because the reaction with cerium is so much faster, it's able to grab that free oxygen before big dumb rhodium can grab it, which leaves rhodium the only choice to get his oxygen from the nitrogen atom. And that's why if a car's running lean, it can't reduce NOx. Just like if a car is running rich, it can't oxidize HC and CO. So unfortunately, a lot of people have a car that fails smog and they just put a catalytic converter on it and it doesn't change anything. Going back to my Lambda calculator, I had that Chrysler that had 2,300 parts per million of NOx, Most shops would have put a catalytic converter on that car and still had the same problem or worse. The problem was a bad O2 sensor because it was running too lean. I put the right O2 sensor in, we went from 2,300 parts per million to 2. There was nothing wrong with the cat. But you see where people jump to the cat because the cat's treated as this magic fix-all. We put it in the exhaust and like magic, it makes the air clean. There's no magic, it's science. And when you understand the science, you are better at understanding what to do and what not to do. So here's an aftermarket converter. So when I'm doing a visual inspection for a smog, I would see this aftermarket converter underneath, and I would have to go in and get the numbers off that converter and ID that converter.
The soldering.
Yeah, here is another one. See how nice and easy that is to read?
Why we study the composition of inside?
Because if I don't understand the composition inside, I can't understand how to test it and how to replace it properly. So the chemistry inside the cat is highly important. If you notice, I don't spend a lot of time inside a lot of things.
Yes, but the only way to test is like the result of the smog on the other side, right?
No, absolutely not. There's several different ways I can test a cat. And on an OBD2 vehicle, I'm not going to measure the smog coming out the other side at all because it's not going to tell me. If I drilled holes in front of it and behind it, it still wouldn't tell me accurately. That's called an invasive test, and it's horrible and doesn't work well. So I can either, on an OBD2 vehicle, I can test it with the O2 sensors.
Right. The quantity of oxygen there
What's
is.
that?
The quantity of oxygen there is on the other side, right?
Well, yes and no. It depends on how the catalytic converter is being. There's two different ways we test cats. One is what's called switch ratio testing, where I monitor the front O2 sensor and I monitor the rear O2 sensor. If the front O2 sensor is doing this and the rear one is doing this, we're assuming that we have some cat function.
Okay. If I see the same pattern, it seems it doesn't work.
I assume there's nothing.
Doesn't work.
So think of the catalytic converter as a shock absorber.
Okay.
Now, not all manufacturers test cats that way. And after some manufacturers never did, Toyota and GM, for example, and by about 2006 to 2010, no one tests the catalytic converter that way. Okay. So now what we do, and I got slides on this, is the computer's actually going to make the system rich.
Okay.
Both sensors read rich.
Okay.
Then it's going to switch lean and watch the front sensor go low.
Okay. Okay.
Count how much time it takes for
Okay.
the rear sensor to go low.
Okay.
That amount of time is the storage capacity of the cerium in the converter.
Okay.
Now, compare that to specs.
This test the computer do.
The computer does, but
Sure,
I can
like
do both those
PCL.
tests myself.
Okay. With scope both sensor.
Right, with a scan
Okay.
tool or a scope,
Okay.
and I can do those tests myself, and I
Okay.
have directions and stuff on how to do it.
Okay.
If I don't have front and rear O2 sensors, now you're right, I do need to use my tailpipe emissions, but
Right.
now it's a question of how I use them, and there's several tests I can do to measure that on which test is better and all that, because not all tests are equal. So, I mean, I have a whole presentation just on testing these. And I know Sam covers more of that in his class. I try to cover it here, but we tend to run out of time. I may try to hit it next week instead of doing some of the other level 2 stuff, since I'm not going to give you a level 2 final, because it's so important to really look at cat and fuel control. And I'd love to touch on that a little bit more, because that's, you know, exponentially a bigger influence on how things work. But you can see how hard this number is to read. This is laser engraved. I have to get this numbers off in order to verify it's the correct converter. The best way to see these numbers, if they're hard to see, is you take a dripping wet shop towel when the catalytic converter's hot, and you actually polish the shell of the catalytic converter a little bit with a wet rag. And yeah, it's really hot. And then shine the flashlight at a 45-degree angle, and you can see all the numbers. So that's how you get them. Because here's the deal. If I can't read those numbers, the car fails.
Mm.
Because the rule says I have to write the executive order number for the catalytic converter
Right.
on the vehicle inspection report. So if I can't get the number,
I need to fail the
I
car.
can't write it on the vehicle inspection report, therefore the car fails. Yeah, Roberto.
Yes. When did Bar started requesting EOs on catalytic converters?
either 89 or early 90s.
Got it. And one more thing. Do we test for NOx the same way in a GDI versus a non-GDI system?
Yeah, from an emission standpoint, or like a bag test that the EPA is doing, absolutely. It's looking at total emissions. We went to GDI to lower total emissions. So because I might make more NOx, maybe I need a bigger cat, or maybe I need, right, there's always compensation. In theory, GDI should make less NOx, because what I'm doing is I'm only compressing air and then spraying fuel. On a conventional system, I'm compressing an air-fuel mixture that might start burning before I want. And if it pre-ignites, then I make huge NOx. So GDI, in theory, should make less NOx. Where GDI makes a lot of NOx is if I try to use a, instead of a harmonious charge, I'm using a, it starts with an S, I'm sorry, I'm blanking on it, a stratified charge.
Okay.
So if I'm using a stratified charge, which no one in this country does because of the high NOx, we do in Europe, stratified charge will give you very high NOx. But that's not a characteristic of GDI. That's a characteristic of how we're putting the fuel into the engine with GDI. GDI is only the tool we're using.
Okay. And is there such a thing as GDI catalyst regeneration?
PDI catalyst regeneration?
Yeah, the GDI.
Oh, GDI. Probably what they're referring to is a NOx storage converter, where they're running rich or lean to get rid of the NOx on the rich shift. And that's probably what they're meaning by that regeneration on a gas engine, like what they, and they do that on the diesel. When we get into diesel, we see regeneration. I'm not going to get there today. When we get into diesel particulate filters, we use regeneration to convert the carbon into ash.
Yes, we do it. There's a process to do that.
Right. But gasoline engines don't have a catalytic regen that I've ever seen. The closest thing to it is the NOx storage converter, where we're using a rich shift to actually get it to, and they use barium in it. The barium is what's actually holding the NOx, and then they use it to release the NOx on a rich shift and allow it to be broken down. And that might be what they're considering a catalytic converter regen. I could see where they might be using that terminology, but that's the only system on a gas engine I've ever seen that used on.
Okay, I saw that somewhere in a book, but
yeah, and there's things I haven't seen, so there might be something out there that I haven't seen or haven't been exposed to, or it might be how they're explaining an NSC converter and they're explaining it a little awkwardly or partially, you know, in a way that would be confusing. Mario, you had a question.
Yes, still differences like the diesel engine and the gas engine, but now today's with high pressure injector, I see almost the same.
Right. Well, the main difference is gasoline is spark ignited.
Right.
Gasoline's combustion ignited. That's always been the difference.
Right, but today's with our knowledge, you easily can work on diesel, right?
Oh, absolutely. Matter of fact, the more comfortable I am with computers, the better I am going to be working on diesel.
Okay, good.
Because
Because
it works much more like a gasoline engine now with common rail injection,
right,
than it ever has before with mechanical injection and nothing to plug into and nothing else. So I think it's much easier to work on diesels now than it was 20 years ago.
right. There was okay. Thank you so much.
Yeah, I mean, it's much easier for people that are trained on gasoline to work on diesel today than it is people trained on diesel to learn gasoline.
Absolutely.
Okay.
I agree.
So, no, that's a great point, Maura, and that's why I don't want anyone to be afraid of a diesel. It's
No,
gotta-
I'm not
it's
like
gotta be
this.
system. We can figure this out.
I'm the only good thing I have, like the language. I'm not
Right.
shy. You know what I mean? I
No,
just
I know you're not
work.
shy.
You have to understand me. You know what I mean? The same in the work. You know what I mean? It's like
Yep.
you have to do stuff.
Yep. Oh, no, I get it. So is this a factory or aftermarket cat?
Aftermarket.
Aftermarket, which means what? I need to go get numbers on it.
Yes.
Here is an aftermarket cat. We can see the numbers on it. I can see the executive order number and the part number, and I'd have to look at the next thing to see the manufacture date. So here is an early three-way catalytic converter with air injection. So we can see the front bed, which was a three-way converter. We used it to reduce NOx. Then we would inject air in and oxidize the HCNCO in the back bed. On these early systems with air injection going into the cat, it was real easy for these catalytic converters to overheat. We were told not to let these cars idle for more than about 5 minutes. And at least once a month, we used to get a car that would pull in off the freeway that the carpet was on fire because the catalytic converter overheated. Because the car would be running rich, and with all that air going in, now we have a blast furnace. It would overheat, get past the heat shield, and cause the carpet to catch fire. And so we used to get about once a month in the service station where they'd pull in off the freeway, literally with the carpet smoldering or small flames. So very, very common back in the day. This is also where a lot of that, if you park on grass, you're going to start a fire. Goes back to this system. What emission does an oxidation converter use to help control?
NOx.
What?
I said NOx.
No, it
No,
helps everything except
oxidize.
NOx.
No,
CO
oxidize.
and
What do I
hydrocarbon.
oxidize?
CO hydrocarbon.
Hydrocarbons and carbon monoxide. That's what we oxidize,
Okay.
right? So this is what we have on the oxidation. Oh, I'm sorry. I see I had misplaced my chat. It was hiding behind all your pictures. Looks like I got the video. Okay, I hardly hear the video. I think I got that. Smog. Okay, I just want to make sure. What's the difference between California and federal cat? Great question. Okay, so the biggest issue is how's the cat certified? That's it. How did they certify it when they got it done? So a California load cat may have a different load to it. In aftermarket, they do. Aftermarket cats on the aftermarket side, California converters have a higher load, more precious metal in them. Also, they've had to go through the testing process with the California Air Resources Board. Federal catalytic converters, we made a cat. Here's the part number. Please buy.
But we cannot install them in California if they're not California
Approved, correct.
approved, right?
Yep. And that's why we check that during a smog. I fail a lot of cars because cat's not legal.
Got it.
So very, very, very common. But that's the difference, how it was certified. And usually, I mean, even in other states that aren't California, good shops put California replacement cats on because they know they're better. A lot of the factory ones won't even keep, I mean, a lot of the 49 state ones won't even keep the check engine light off. They're horrible. So here's a warm-up three-way cat. Keep in mind, this is still a three-way cat. It's called a warm-up three-way cat because it's mounted right against the engine or right against the exhaust manifold. What emissions is a three-way converter used to help control?
CO, HC, and NOx, all of
You
them.
got it, all the above. So the two things you need to remember: oxidation. We oxidize HCnCO. We turn it into H2O and CO2. We're adding oxygen. Three-way cat does everything. Reduction cat is NOx. We reduce NOx. We break it to oxygen and nitrogen. Another thing is we use rhodium to reduce NOx. R&R, rhodium reduces. Platinum and palladium are used to oxidize HCnCO. So that kind of, that's how I remembered the elements and what's going on inside there. So here's a heat shield right here. Kind of shows the, can help with this location. If we're replacing a catalytic converter, I have to install the converter in the same place. I can't move the converter. I can't add pipes. I can't move O2 sensors. There's a lot of limits on that, and I should put that into our resources. That's on the car ARB website, and I should move that over into our shell. I didn't think about that, and I'm gonna.
I have the heat shield, the protection for the heat. No, that's why.
Yeah, the heat shield's protection from heat. We see we have underneath to kind of protect the grass and things like that. And we have them underneath the carpet, underneath the floorboard to help keep heat out of the driver's compartment. And we do that for a couple reasons. One is if I put a lot of heat in the driver compartment, that means I'm gonna have to run the air conditioning more in order to what? Cool the car. So now I'm wasting energy. So the heat shield, we're using it to try to save energy a little bit. We're also using it for, protection. And so multiple reasons. Let me see if I have, there we go, converter function and testing. Let's put the same data on it, the newest one. I'm gonna pull up a slide here off of another PowerPoint, and I think it has what I want in it. It does. All right. So I am going to, okay, so I just changed here. This right here is a graph that I copied out of a book and built. And what we have here is one lambda right in the middle. This is a good catalytic converter. Here's my percentage of efficiency from 10%. Here's 50%, 80%, 100%. So we said our acceptable range for lambda is 0.980 to 1.020 to be in fuel control. So if I come over here to 0.980, I see that my oxidation efficiency on a good converter is really under 35%, certainly under 40%. If I go lean, 1.020, my reduction efficiency is under 40%. So you can see how sensitive lambda is to my converter's efficiency. So if my car, say I'm running a 0.995 lambda. So 0.995 lambda is going to intersect me right here. So if I'm running just slightly rich, I'm going to make more hydrocarbons. I'm going to make more carbon monoxide. So I oxidize those in the oxidation bed. What just happened to my oxidation efficiency right here? It dropped 20%, didn't it? So I'm making more HC, I'm making more CO, and I have 20% less efficiency in my catalytic converter to get rid of those. You see where the cat, it's really cool what it does, but this is why I talk about the chemistry inside it, Mario, because if we're going to diagnose these vehicles, it's not just what's coming out the tailpipe, it's what's my lambda, right? Say I have a car, and boy, you're right, it's not oxidizing HC and CO worth a darn. But wait a minute, my lambda is 0.96. That's only 25% efficiency on a good day. How about I go the other way? I've seen cars, 1.040 on NOx. I'm right around 15% converter efficiency. I've seen people replace converter not only once, but a second time.
Wow.
And a third time, because the cats are all defective because they keep getting the same results out the tailpipe. They never check lambda.
But the third one, I mean, it's summoning. The second one, I can understand. But the third one.
Right. It's like keep buying a new computer, bringing it in, plugging it into the wall, and going, the computer's defective, and never checking the power in the wall. Okay, so that's why I built this slide. I use this in my diagnostics presentation. But you can really see the effect of fuel control on my emissions. I can see the effect of fuel control on the catalytic converter. So when we tell people, that's why test onlys don't give diagnosis, because I haven't run the Lambda calc. I haven't tested the cat. So I have no idea. Just because the car's failing smog doesn't mean it needs a cat. Just because I have a catalytic converter code doesn't mean it needs a cat. And I got a video I'm working on putting together to show that on a case study. So, and unfortunately, people that don't want to pay for diagnosis because they don't have a lot of money end up taking off a perfectly good factory cat and going and buying a piece of junk. Their car still fails smog. It may even fail smog worse because what? Their fuel control is not right. You know, and unfortunately, you know, that catalytic converter is seen as a magic thing. It's not magic, it's science. There's certain things it will do for me. There's certain things it won't do for me. And so I really want to look at that so I can make an informed decision. I've had plenty of customers come in and they actually ask for a catalytic converter because they fail smog. I tell them I won't put a cat on until I do a diagnosis because A, it's the wrong thing to do, and B, because it's illegal. But, you know, they don't want to pay me for the diagnosis sometimes and they go on. Other times they pay me for the diagnosis and guess what? They didn't need a cat. We fixed the car without replacing the cat. And I can tell you that's probably 80% of the time. So, unfortunately, catalytic converters kind of have this reputation as being the magic. If your car doesn't
The
run,
problem.
it needs a cat. Right? It's the magic Band-Aid. I've actually seen people put extra cats on cars, which is not legal. But I had a customer came in, they had 5 catalytic converters in a row underneath their car trying to get their car to pass smog. Fundamental misunderstanding of what the converter does. And by the way, not only did it not pass the visual inspection, it didn't pass the tailpipe either. It was still running dirty. So you can really see the effect that mixture control has on our catalytic converter. That's why when a car fails smog for tailpipe, the first thing we do is check Lambda. Pretty interesting.
Mhm.
Okay, so now let's look a little bit of diesel emissions. I want to finish this up today.
Oh, it's already 10.
Come on. All right. Reopen it then. Okay, so diesel emissions. And I mean, we could spend a week on diesel emissions, but I want to give you at least an overview here and why we have them. I like this slide here because it really shows, we look at the big box from 1994, the 98, 2002, 2007, 2010. This is when the regulations went into effect, and we told the diesel industry you need to clean up your act. What's interesting is the regulations for 2010 were made before 1998. So the industry was told, this is how clean you need to be. This is how long you need to have to get there. There was no technology available at that time for us to get a diesel to run that clean. And we traditionally do this with vehicles where we legislate standards where technology is not yet available, and then task vehicle manufacturers to develop the technology in order to meet those standards, which is also why some of that technology doesn't always work so good the first year or two, because it's brand new. It's just been invented. The other thing that's interesting here is that all these emissions are per horsepower. So two things have happened with diesels in the last, during this time from 94 to 2010, and we see it continue today. Diesels, besides running cleaner, produce a lot more horsepower. They produce a lot more horsepower because if I make more horsepower, I don't have to be as clean. Are you following the logic here? If I make 100 horsepower, I'm only allowed to put out so much. But if I make 200 horsepower, I can put out twice as much and I'm legal. Kind of a neat trick, isn't it? So 2007 and older emissions, or 2007, we see the diesel oxidation converter and diesel particulate filter. 2010 to 2013, we saw the selective catalyst reduction come in, the SCR, and that's what takes the AdBlue or the DEF fluid, or the, which stands for diesel exhaust fluid. So that is, or AdBlue if I'm working on a European car. And we actually use the AdBlue as the catalyst in this. So the SCR is actually a frying pan, and we add the DEF solution, and that's our catalyst. And we actually use that in the process. And that's why customers have to buy the DEF fluid and put it in. So inside our SCR, all it has is steel and copper. Sounds like a Revereware frying pan to me. So all that is a frying pan. It should never wear out because it's just a frying pan. So what we're doing is we're putting that DEF solution in. So diesel exhaust systems can look a lot different. I do have oxygen sensors here, but look at my diesel oxidation converter up front. Then I have a NOx storage converter, and I have an H2S converter, which is for sulfur. What is that? 2 hydrogens. So it's going to be sulfur dihydride, I think, or sulfur. Anyhow, been a long time since I was in chemistry, but you get the idea. It's for the S means sulfur. You had a question, Umberto?
Yes, I do. Who is watching the AdBlue level in this system?
Who is watching which levels? The emission levels?
The AdBlue.
Oh, let me get to SCR and we'll talk about that.
Okay.
Okay. So diesel detection. This happens to be a Chrysler. We got some acronyms here. CAC, charge air cooler. That's for a turbocharger. DDI, diesel direct injection. EGR, heated O2 sensor. NAC, NOx adsorber converter. Doesn't actually absorb the NOx. It just holds the NOx on the surface. An oxidation converter, a particulate trap oxidizing converter, which is the PTOX, and turbocharger. And there's a picture here out of all data that shows me where all the pieces are. So if I've never smogged one of these before, you can see the underhood label. It's all Greek to me. Let me go get a picture. I'm not the sharpest guy, but I guarantee you, if you give me the truck and you give me the picture, I can look underneath there and see if all that looks the same. I bet you guys can do that too. So a lot of this is not knowing everything by heart. It's knowing where to find the information so I don't make bad decisions. The biggest enemy we have as a smog tech is being lazy. I'm sure it's okay. I'm not going to look underneath the car. It looks like it's fine. I'm not going to go look it up in the book. I'm sure it's all there. When I smog a car, every car fails until it proves everything is correct, and then I'll pass it. Where people get in trouble is when they start doing a smog and go, I'm sure everything's fine unless I find something wrong. That's going to make you sloppy. It's going to make you cut corners. every car ice smog fails until that car proves every piece is there that's supposed to be there. And that's why I don't make that mistake. So here is a Ford exhaust system. And you see this looks a lot different than our gasoline converters, doesn't it? These are huge. A lot of times they're all one piece from the factory. They're replaced as one piece. And we can see I have my diesel oxidation converter first, which is always the first part, my selective catalyst reduction second, and my DPF third. Depending on the weight of the vehicle, the DPF and the SCR can be reversed. Depends on the weight class of the vehicle and the manufacturer. So my diesel oxidation converter is just that. It's an oxidation converter. And I have an exploded view. Does the honeycomb look familiar? We're going to oxidize HC and CO. NOx is still going right through because NOx doesn't care about oxidation. It already has enough. And so you can see the chemical reactions here on the DOC. Diesel particulate filter, we have two types of diesel particulate filter, open and closed. What we use on light duty vehicles is a closed type, which gives a much higher efficiency. It means unlike our gasoline, an open type would be like our gasoline converter. I got a honeycomb and I can see through it. What they do on a closed type is I go down through this channel and it stops. Now I have to go through the material in order to get to a channel that's open at the other end. So every other channel, one's open at this end, the other channel is open at the other end. It has to go through the material. It's a filter. One of the primary purposes of this filter is to prevent smoke. So if you have a newer diesel that's smoking, either the diesel particulate filter is bad or missing because it's going through the filter media. It can't go through the filter media because of the micron size of the smoke. Therefore, the filter has either been punched out or it's missing altogether on a vehicle that's smoking. On newer diesels. And it talks about this, and it has some pre-selection filter in it. Here's a picture of one right here. These are measured for pressure. So they may have a pressure sensor front and back. They may also have a NOx sensor front and back. There's a couple different ways they measure these. When these get full, the vehicle will do what's called a regen, where it gets this up to over 1,000 degrees and melts the carbon, it burns it and turns it into ash. Once this thing's full of ash, it's done. Once it's done, we have a couple choices. There are shops that'll bake these in an oven to get all the ash out of them, or you're buying a new one. When you go to heavy duty stuff, these are held together with bolts and nuts, and you actually take them off, unbolt them, take the filter out, and send the filter out to be cooked in an oven. So if I'm running like a tree trimming truck, or I'm running a city truck that's spending a lot of time at high idle, 1,800 RPM and not going anywhere, or just low idle, a lot of sitting around, I might plug this up in a month. If I'm driving it, going down the road, acting normally, it'll do its regen. I'm good for a couple 100,000 miles. So it really depends on how I drive the car. If I'm using my truck for a lot more towing, I'm going to fill this up sooner. If I put a tuner in my truck, I'm going to fill this up sooner.
Maybe that's some of the money that's going to our coming out of our taxes with the city. They're idling too much.
Yeah, but they got to idle. So a lot of it's to run their computers. That's why police cars have to stay running. Their battery system's not enough to hold to get the car to start with all the computer and electronics they got running. And
True.
The air conditioning if it's a canine unit.
That's true. And diesels, from what I read, they tend to idle for a minute, even when you turn them off.
Diesels are neat because I can actually idle a diesel very efficiently, much more efficiently than a gas engine, because gas engines always have to work pretty close to stoichiometry, pretty close to being stoichiometric. Diesels, I can idle them as lean as 100 to 1.
Would you say that most places that decide to want to bake them and get the soot out, they would pay for that rather than just getting a new one? I mean, is it?
Oh, absolutely, absolutely, and that's big business. From what I hear, there's a shop in East County, I think it's El Cajon, Santee, somewhere out there, that actually does this for the local diesel population, because I asked them that when I was teaching the 6-7 class. I know up in the LA basin, there's a couple shops. Even up in Bakersfield, there's a shop that does. So, you know, there has to be enough of a population for a shop to have an oven and do all that stuff. But it's normally a shop that their whole job is just baking these things. They may not even work on vehicles, or if they do, all they do is take these on and off to bake them. But a lot of it is sublet work from other shops, where other shops are taking them off, bringing them to them, and they're there all day just baking these things. Some of them actually have pickup and delivery, just like a machine shop or a parts store.
That's awesome.
So another thing we could use, like I say, we use pressure sensors here several different ways. Here's a diesel particulate filter that's actually on a vehicle. And I do have a little video on diesel here that I'm going to play. And I got to find a new one, because this one, even though it's paid for by our tax dollars, doesn't have closed captioning. So I'm going to use it this time, but I got to find one with closed captioning.
For sure. Thank you for that. I'm going to take a look at some of those companies.
Quality specialist with Washoe County Air Quality Management Division. This is a short educational video about particulate matter, what it is, why we're concerned about it, and where it comes from. So what exactly is particulate matter? It's a pollutant found in the air that includes dust, dirt, soot, smoke, and liquid droplets. Particulate matter, also known as PM, is a year-round pollutant, but is of greater concern, especially in our region, during the winter months, due to temperature inversions like the one shown in this photo.
Well, great. I think I screwed it up now. You notice how they said the problem they have is in the wintertime due to temperature inversion. In LA basin, it's the summertime due to temperature inversion. So a lot of our mountain communities that are built in valleys, they have smog in the winter, none in the summer. LA basin, we tend to have here. So it's interesting how that cycles. And that's also why we don't have a lot of the same smog problems in places like Chicago or Cincinnati or New York. Why? Because they're not in a basin. It's all flat. They can't create that inversion layer to create the smog. And that's why we don't have smog programs in some of these big cities, but yet their cars are polluting like nobody's business. And no one checks, because they don't have a program, because they're meeting clean air standards, because the smog they make in Chicago is blowing east to Pennsylvania and out over the Atlantic. Apparently it's not going to let me. Come on. It's mad at me. I might have to back. Let's try this. I made it mad. Open shop.
Hello, my name is Janine Wright. I'm an air quality specialist with Washoe County Air Quality Management Division. This is a short educational video about particulate matter, what it is, why we're concerned about it, and where it comes from. So what exactly is particulate matter? It's a pollutant found in the air that includes dust, dirt, soot, smoke, and liquid droplets. Particulate matter, also known as PM, is a year-round pollutant, but is of greater concern.
Oh, this thing is just not happy.
Especially in our region during the winter months, due to temperature inversions like the one shown in this photo. During these inversions, pollutants can be trapped for several days at a time, basically until the weather changes and the inversion breaks and the wind blows it out of the valley. There are two sizes of particulate matter that are regulated by the EPA. Particles between 2.5 and 10 microns are called coarse particulates, or PM10. These are of concern to human health as they are small enough to be inhaled and accumulate in the respiratory system. Particles of 2.5 microns or less are referred to as PM2.5 or fine particulates, and are a greater health risk than PM10 as they can reach deeper into the lungs. So how does particulate matter affect my health? Children are especially susceptible to the effects of particulate matter as their respiratory systems are still developing. The elderly and adults with chronic heart or lung diseases are also more likely to experience the effects. However, healthy adults can also feel these effects from particulate matter. Fine particulates, as I mentioned before, can get deeper into the lungs and cause serious health problems such as decreased lung function, aggravated asthma, development of respiratory disease in children, irregular heartbeat, non-fatal heart attacks, premature death in people with heart or lung disease, increased susceptibility to heart and vascular disease for postmenopausal women, and increased risk of lung cancer. So where does particulate matter come from? PM10 or coarse particles come from crushing or grinding operations and dust from construction or unpaved roads. Fine particulates come from combustion activities, including wildfires, power plants, some industrial processes, motor vehicles, and wood burning, such as in your fireplace or wood stove. Our burn code is in place to help reduce the wood smoke in the Truckee Meadows, as this accounts for nearly half of all the PM 2.5 during the winter months. For more information about particulate matter, visit us at ourcleanair.com.
So I thought that did a nice job of kind of showing the particulate matter, also showing that the small particulates are really the most dangerous, and the Bureau training does that also. I'm sorry I couldn't get the volume up any higher. I saw someone message me. That's why I kept pausing. I kept trying to change things. And the inspector update training also talks about particulate matter and the health effects from it. So that's why we have a lot of the stuff we put on diesels. We are really concerned about particulate. That's the new thing we're really focusing on over the last 15 years. And it's really dangerous because that 2.5 gets in the lungs and we can't get it out of the lung. It creates permanent damage. So that adversely affects communities that live close to industrial areas, close to freeways, close to where trucks might be traveling. And we see those health effects disproportionately affecting people that live in those areas. Consequently, people that live in those areas tend to have less income than people that are living in other areas because trucks aren't coming down my road, right? But if I lived in San Diego, if I lived over about one of the main roads down there, Logan, 30th, any of that stuff, if I lived right by the 805 or the 15, trucks would be coming by all the time. I would be breathing a lot more of that PM 2.5. And that's why we're going after that, is because of the severe health effects that causes. And 2.5 is small enough, it can remain airborne almost indefinitely. So it's not like it just falls next to the surface. The PM10 doesn't go nearly as far. The PM 2.5 can actually reach the upper parts of the atmosphere. So that's your fine, real fine particulate matter.